Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, at DG Khan campus. Dear students, our today's lecture topic is MAC. MAC stands for Media Access Control. So in this lecture, we will discuss about MAC sublayer, multiple access protocols, CSMA/CD and CSMA/CA. CSMA/CD stands for Carrier Sense Multiple Access with Collision Detection, and CSMA/CA stands for Carrier Sense Multiple Access with Collision Avoidance. Whenever we will use different types of networking topologies like bus topology, star topology, ring topology, mesh topology, and so on, there must be some mechanism to control the collisions in those topologies or physical networks. When bus topology is being used, there is no centralized device which is being used to control the collision mechanism or collision problem. So there are two different protocols, CSMA/CD and CSMA/CA, which are being used to control the collision problems in bus topology especially. So we will discuss in detail about these two protocols as well as MAC sublayer in today's lecture. MAC sublayer, this chapter deals with the broadcast network and their protocols. So this chapter means today's lecture. In our today's lecture, we will discuss about broadcasting and different protocols regarding those broadcasting or those broadcasting issues. In a crowded broadcast network, we are interested to see who gets the channel when there is competition for it. Let's suppose there is a channel, there is a path, and there are 2 or 3 devices which want to transmit data at the same time. This is very important. If these devices wants to transmit data at the same time, there must be some mechanism to control the data transmission, because at the same time these 3 devices would not be allowed to send data in the form of signals, because when the signals will be on that channel at the same time, there will be collision. Third point, let's look at the example of a conference of 6 people. So if there is a conference and there are 6 persons who are attending that conference, if they will start to communicate each other at the same time, it would not be possible to listen the voice or the voices of the whole conference participants. So if one person at one time will speak, the other 5% will be able to listen carefully. So this scenario is also available in our network. When one device wants to transmit data, just that device will be allowed to send data and all other devices have to wait. MAC sublayer or medium access control sublayer. In the conference, one is talking and all are listening. Let's suppose if we talk about the lecture in our class, there are 30 students and there is one teacher. 30 students are listening and one teacher is speaking. So in this way, all the students will be very careful to listen the lecture of their teacher. So this is an example of conference, or this may be example of class and so on. Second point, when one stops talking, it's likely that 2 or more people start talking at the same time, leading to chaos. Let's suppose if 2 students or 3 students or 4 students will start talking at the same time or simultaneously, it will not be possible to listen the voice of any student, because there will be problem like collision in our network. Here no one can understand what the speakers are trying to say. In other words, the voice of the people are mixing up. This can be avoided if people raise their hand and wait for their turn to speak patiently. So in class, if there are questions from many students, one student will raise his or her hand and the teacher will answer the question of that student, and likewise every student can ask the question, avoiding the problem of collision or avoiding the problem of noise in the class. Max Sabler. The protocol used to determine who gets next on the multi-access channel belongs to the sublayer of data link layer called the medium access control sublayer. So what is decided by the protocol means when a device will transmit data is dependent on the protocol, and this is deployed on MAC sublayer. The MAC sublayer is very important in local area network as well as wide area network, because in any network if there is problem of collision, then the data have to be retransmitted, and when the data will be retransmitted, there is again cost of network. We have to reassign the resources to that network devices. So collision is not good in our network, and to avoid collision it is very important to control the collision problem with the help of some mechanism, with the help of some protocols. So there are some protocols which are used to handle the collision issue in LAN as well as WAN. Multiple access protocols. Theme of this topic is how to allocate a single broadcast channel among the competing users. So if there are more than one users who wants to transmit data at the same time, if there are 10 users and those users are not using the channel at the same time, then this will not be created, this issue will not be created. But if two or more than two devices wants to transmit data at the same time, then those devices will be competing, and definitely devices are handled by users, so there are 3 or 4 users who are competing for that specific medium. Second point, there are many protocols known, but we will dealing with two protocols, Aloha and Carrier Sense Multiple Access. So these are two commonly used protocols or mechanism which are being used to control the problem of collision. I am repeating again and again, the issue which is created by the simultaneous use of a network resource which is a medium is called collision, because if more than one devices will transmit data at the same time, that data will be collide, the signals will be collide and data will be lost, and we have to retransmit data. So there are two mechanisms, two protocols, Aloha as well as CSMA, which are being used to control the collision issue. Aloha. Aloha protocol was first proposed in 1970s by Norman Abramson at the University of Hawaii. You know that in all over the world, research is very important. The system of education in all over the world leads the research oriented network, research oriented different organizations. So these organizations or these network create a group of researcher, and those researcher create different technologies, different softwares, different ideas and so on. Second point, it is applicable to many systems in which the uncoordinated users are competing for the use of a single shared channels. So we have discussed in our previous slides, there is a single channel, there is a single medium, and many users, many devices are competing for that channel at the same time simultaneously, because this issue will be created when multiple users will try to access the channel simultaneously. Last point, two versions of Aloha is known as pure Aloha and slotted Aloha. We will study in detail regarding these two protocols in our coming slides. Pure Aloha. The basic idea is very simple. In the previous conference, if people never care to see if it's his turn or not, he always speaks. This is Aloha. It means that there is no mechanism to control the collision. All the persons maybe speaks. It is possible to listen the one's voice, or it may be impossible to listen the one's voice. So like different persons in a meeting or in conference can speak at the same time, likewise multiple devices can transmit data at the same time. The second point, the user transmit whenever they have some data to send. Simply the devices will transmit the data. Next point, there will surely be collision and the colliding frames will be destroyed. Of course, if more than one devices will transmit data, there will be collision, and due to that collision signals will be destroyed and you have to retransmit those signals in the form of definitely data. Due to acknowledgement feedback, the sender will know whether or not the frames were destroyed by listening to the channel. You know that when the data is being transmitted from source to destination, destination device will send acknowledgement. That may be positive acknowledgement or that may be negative acknowledgement. If there is positive acknowledgement, sender will transmit the next frame, and if there is negative acknowledgement, the sender will retransmit the frame which is being destroyed or which being lost. So this is the concept of pure Aloha. Pure Aloha, you can see there are three packets, packet A, packet B and packet C, and you can also see vulnerable time. This is time in which collision may occur. So there is also shown wasted time. So collision between B and C, you can see that collision between B and C as well as collision between A and C. So if more than one packets are there transmitted by different three users, packet A, packet B and packet C, this packet will be collide because these packets are being transmitted at the same time and you have to retransmit the packets. Collision of packets occurs when a packet overlaps another packet, means a packet is being transmitted at 8 am, let's suppose, and another device transmit the packet at the same time, then the channel will be used by two different users, and this is collision, and in this case there is only one solution, data retransmission by sender. Pure Aloha. In case of local area network, the feedback is immediate, but in the case of satellite, there is minimum delay of 270 millisecond. In local area network, when we will transmit data, we will receive the response, but in the case of satellite, there is some delay. Second point, if the frames were destroyed, the sender need to send the frames again. This is very simple. If the data has been lost, then you have to retransmit the data. Next point, the waiting time is random or else collision occurs again and again. Normally, when the data is being transmitted from sender to receiver, sender device will wait for some specific time, about acknowledgement, positive acknowledgement or negative acknowledgement. So that time is very important. If the sender will not receive positive or negative acknowledgement in that specific time, sender will retransmit the frame. Last point, the system in which multiple users share a common channel in a way that they can lead to conflict widely known as contention system. You have here a medium bone of contention. So this system is like contention system because more than one devices, more than one users are going to transmit data at the same time, and collision will occur and the system will collapse. So there must be some mechanism to control this issue. Pure Aloha. In this diagram you can see there are 4 stations: station A, station B, station C and station D. These are 4 different devices and these are transmitting different frames, and you can see different frames of these devices. There are 3 main points over here. Point number 1, the white frames are errorless frames because there is no overlapping time between A and C, because white frames are being transmitted by A and C, and you can see there is no overlapping time. A frame has been transmitted and then C frame is going to use that channel. Second point, the black frames all collide and encounter error. You can see in the color of gray or black, you can see the overlapping, and due to this overlapping data will be collide. We can observe contention in the above figure. All those frames which are in the color of gray or black, those are basically a reason for contention, and the data of the whole different 4 stations will be lost. Next is a slotted Aloha. The slotted Aloha was designed in 1972 to double the capacity. We will see in the next diagram regarding slotted Aloha. Second point, time is divided up into discrete intervals corresponding to one frame. It means if we have 1 second, and in pure Aloha in 1 second there is only one device which can be able to send data. So in slotted Aloha we can divide 1 second into 2, 3, 4 or 5 different portions, and in one portion one frame is being transmitted. So if the 1 second is divided into different discrete intervals, 5 intervals, so in 1 second 5 frames can be transmitted. So there are less chances of collision over here. Next point, during this slot the frames are transmitted. Each node must agree the slot boundaries. So every data transmission is bound to that specific time period. The transmitting frame emits a signal at the start of each slot to let others know that channel is busy. So if the channel is busy, you can't be able to transmit data. This is like that if you are talking to any person on your cell phone or traditional PTCL number, there will be busy tone for that person who is calling you, because 2 persons are already talking. If the third person will call you, definitely your number will be busy and he or she can't be able to talk to you. And the last point is, it can also happen that 2 stations broadcast at the same moment, the packet collide. But if the again problem is, if the same time 2 stations will transmit data, the packet or data will be lost. Slotted Aloha, here you can see packet A, packet B and packet C. Vulnerable time is again between packet A and packet B. There may be collision again between packet A and packet B, but because packet C is at different time space, there will be no collision. Rather than sending a packet at an arbitrary time, send along time slotted boundaries or slot boundaries. Collisions are confined to one time slot. So over here you can see the packet B and packet C. If some specific time is allocated for packet B and then some time is allocated for packet C, there will be no collision. But between packet A and packet B, there is no allocated time, so definitely there is collision. You can see over here, this is overlapping frame concept, so we must control this mechanism by some other technique. Slotted aloha, over here you can see again two format of frames, white frame and gray or black frames. So you can see dotted lines over here, and these dotted lines are used to allocate time. You can see again white packets or white frames, there is no collision, but when you will see the gray or black frames, there is collision. So collision can be avoided to allot some specific time slot to every frame or packet. Slotted aloha, the nodes must wait for a fraction of second before they transmit. So this is pure controlling of collision issue. Each and every device have to wait. Second point, synchronization can be achieved by having each station emit signal at the start of each interval like a clock. So every device will use the clock, and when the station will transmit the data, the channel will be definitely 100% free. Percentage of collision reduces to 26%, although this is not 100% solution of collision, but using slotted aloha approximately 25% to 26% or 25% collisions may be reduced. So when we allot some specific time to every specific frame or specific device, then there are maximum chances the collision will not be occurred. So we have discussed in detail about Max sublayer, about different mechanism to control the collision. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you.